Okay. So now let's start with a software called Tinkercad. I hope most of you also just showing like what to I just type Tinkercad and or indirectly open source website called web app where we can do designing, basic modeling. It's all we can do. Here also we can organize I log in with my foundation coding. Here, you will find various options. One is 3D design. You can design the blocks and all. You can also do code blocks. Code blocks is a different thing. We'll explain later. Circuits. Circuits different types of ordinal circuits. So what I'll do is once you are newly logged into this Tinkercad software, you will get a plain sheet.
Is it clear like this?
Yes, sir.
Okay, thank you. So what I'm trying to say is, once you log into the Tinkercad software, you will get an option called Create in the right side. If you click on that, there will be three different options. One is for 3D designing, other is for circuit, and third one is for the code blocks. So as we are dealing now with the Arduino and microcontroller stuff, we should choose an option called circuit to build our own circuits. So if you click on the circuit, you will find this kind of a screen with a basic component on the side. This is what the initial screen you can see with a resistor, LED, push buttons, potentiometer, and all stuff. Now, if we click on Arduino, you will find a couple of already readily made circuits like breadboard, blink, fade, button, debounce. This kind of already pre-built circuits based upon the Arduino, Uno. So now our major thing is on the blinking LED. So I just, you can just click on here and you can drag it to just get placed of the component. So now if we observe, as you already know, understood how, what are the components and what are the pins we do have in Arduino, I'm just briefing it again. In Arduino, we will have a 14 digital pins. Digital pins are basically do operation only either 0 or 1. That means either low or high, on or off. So other than that, one second. Yeah, sorry. So other than digital pins, we do also have 6 analog pins, A0 to A5, which are 6, which will do analog operation, which is not a digital operation. That means it will sweep the outputs. The range of analog outputs or inputs in Arduino, is 0 to 1023. That means total 1024 samples what we can achieve using analog pins. So other than this analog and digital pin, we do have a couple of power pins in which where you can find a VN, which is an voltage input, and other two are grounds. One is 5 volts output, 3.3 volts output, reset, and IO reset. IO effect, sorry. So these are all the different pins available in the Arduino Uno. First thing is like, how do we power on this board? There are three options to power on this board. One is using the D connector, which is here, this one. The other one is using a DC jack, and third one using a VN. So if you want to turn on this board, you can connect a 9 volts battery to VN and ground, then this board will turn on. The minimum voltage required to turn on Arduino is 5 volts, and maximum it can go to 12 or 24 based upon the manufacturer from where you are getting this board. Also, the same D connector can be connected to your laptop or your PC or directly with the mobile charging adapter to your socket. In the DC jack also, we choose the same rated adapters like 5 volts 1 amp or 5 volts 2 amps, range starting from 5 volts to 24 volts is what we go for. So now another feature in this Arduino is whenever, sorry, if we don't have LED, there will be an inbuilt LED in this board. When we are understanding the board, we seen there is an LED called L. This LED will always connect it to the 13th pin. So if you don't have LED, then you only have Arduino board, what we can do is you can directly write the program to work with the 13th pin of your LED board, of your Arduino board. Now let's see how to write the program into this. So now I placed an Arduino board. There is an LED connected physically to a 13th pin. Now if you see here, there is an option called code. Let me click on this code. Here you should select text and you click continue. So the options are simple. You will click on the code, then here you will click on the text and your Arduino program will get opened here. So as we already seen Arduino program, we will have two sections. One is setup section, another one is loop section. In setup section, we generally set up or like set all the pins which we are trying to use in this particular project. So my first project is to connect an LED to a digital pin. So first pin, what pin? Here you can write directly 13. And what is the mode of this pin? That means this 13th pin should work like as an output pin or an input pin. We will have two modes, input mode, output mode. So we should define which mode of operation this 13th pin should perform. In here, now LED should turn on. That means from 13th pin, we should get a 5 volts output. So we need to write the mode of operation will be output. The syntax should follow like this only we should write. Pin mode only M is capital and out mode all letters should be capital. Then okay, now we set up the pin, 13th pin. Now it will work as a digital output pin. Now what operation it should do, when it should turn on, when it should turn off, how much time it should wait and all, we will write in the loop. Loop section, whatever we write, whatever instructions we are putting in the loop section, all those instructions will repeat infinite times until you turn off the board. So here first I wrote digital, right? Because the 13th pin is the digital pin. So So 13, pin is digital, and what it should write high. That means it should give 5 volts as an output. Then delay, wait for 1000 milliseconds. All the operations in Arduino Uno is considered in milliseconds. So 1 second is equals to 1000 milliseconds. After 1 second, again, digital, which pin is 13, what it should write low. That means off, and wait for 1 second. Now let me run this program. So start simulation. So when the board is turned on, you can see LED is on, off. For every second, the LED is turning on and off. Similarly, like along with this LED, you can see there is one more, as I told you before, there is an onboard LED in the Arduino Uno. So that is also blinking, if you guys can observe. So this is the way like how we program Arduino Uno boards with a basic LED. Now let's modify this program into a different story. Let me create a one more LED now. Before that, let me stop simulating. Let me close the code section. I'll just will create a one more LED. I'm just selecting this component, or if you want, let's go to basics, components, basics. Let me pick one LED. If you want, we can take resistor. If not, we don't need to take the resistor. We can directly connect as well. So cathode will go to ground. I'm just attaching to this ground. So, let me just attach this to the. You can click near the terminal and you can get the wire direct. This anode, let me connect to the 7th pin. This. So this is how I made a connection. So one is going to the ground and one is going to the 7th pin. Now I would like to modify this code in such a way that after turning off, like after turning on and turning off this LED, then this LED should glow. The quite simple method is like first I should define what pin I'm using and what is the mode of it. Now I'm connected to 7th pin. So 7 comma output, bracket close and semicolon. Now I made all the setup, all the settings to use the pins in the Arduino board. Now after completing this operation, after 13th pin on and off, I want to turn on the 7th pin. So digital, right, 7 comma 5, semicolon, delay, and let me give 500 milliseconds. That means like off second. Digital, right, 7 comma low, delay, 500. Let me start simulating this. So now LED 1 is on and LED 2 is on, and after half second it's turning off, it's turning. Now let me decrease this delay as well. So that I should stop simulation. This also let me make 500. Make 500. Start simulating. On off, on off, on off, on off. So in the similar fashion, we can make a different LED patterns in this circuit. Is it clear? Or you guys have any questions here? Removing the stuff so make it more visible. If you want, like as in the C++ programming, if you want to write any comments, you can use double slash. If you want to write a multiple comments, slash star, and ending with star slash. This is the way we can define the comments. Let me write first Arduino program. Any questions here? If there are no questions from your side, let me move to the different topic. Now, let's go to Artina section again. Now, we had seen, remove all this stuff. If you want to remove, you can click that particular component and you can press the delete option. Now we have seen the digital operation on and off. Now let's try analog op. That means like fading. I want to fade the LED. That means I need to change the brightness of the LED. That's how I can achieve. So generally fading means what? The brightness should be controlled. Like let me just directly run this, then you might understand what's happening here. So see here, the brightness is like slowly glowing and decreasing. The brightness levels are changing. If you also observe here, this is connected to the ninth pin. Ninth pin is a digital pin or an analog pin. Can someone text that at least? Is a ninth pin is a digital pin or an analog pin? Guys, come on. You should be active while learning this. As you can see in this board, is the ninth pin is a digital pin or analog pin. Yeah, thanks. So yeah, but what we learned previously, digital pin will give only two types of outputs. One is zero, one is one. That means on or off. But if you see in this case, the LED brightness is changing. It means like it's changing from zeroth level to different level. It's not stable. It's not giving direct off or direct on, but there is a fading happening here. Then if we see the digital pin concept, this is not the true criteria. But what happening here is, yeah, as someone messaged Jitendra Sai, it's PWM. If you see in this board, you can identify six negotiated marks. So if you see for 3, 5, 6, 9, 10, 11, you can see a sign here. This sign is called PWM, which is nothing but pulse width modulation. Generally, analog signal will have a waves. This pulse width modulation will have a square kind of a wave. I'll show you once we are discussing on analog. I'll show you the difference of both. So this 6, 3, 5, 6, 9, 10, 11 will work as a digital pin as well as a PWM pin. Whenever we need to have some particular amount of this kind of operations, then we will use PWM pins. We can use analog pins also in this case, but generally preferred is PWM. Why? We will discuss when we are learning analog pins, because there are some limitations when we are using analog pins directly. So in such cases, we will prefer using the PWM pins. Now let's see how this code has been written. So what happening in this code? Let me stop simulation. Let me click on the code. I'll change to text. I'll just remove all those comments. So here, if you see, initially, let's talk about this a little bit later. In the void setup, I defined ninth pin as an output pin. Yeah, that is what we need because LEDs, we should get an output from the board. So here, if you see in void loop, they written a condition, looping statement. For brightness 0, brightness less than 255, brightness plus 5. So what happens here is, so LED, if you guys already in the final year, if you have signal systems or digital image processing, the brightness levels of LED will lie from 0 to 255. That means 256 brightness levels, what we generally get from all types of LEDs. So in that case, we considered initial brightness as 0. As this brightness levels vary from 0 to 255, as is all are integers, we named this variable as a integer data type. So we are taking an integer data type variable, which is called brightness. Initial brightness value is 0. In setup 9 comma output is common. Now what we need to do, we need to change this brightness level from 0 to 255, and we should come back from 255 to 0. So for that, I'm using a for loop. As you already know the for loop condition. So for initial brightness is equals to 0, semicolon, brightness should less than or equal to 250 because this is the maximum level. Now, how I should change this brightness? If I want to increase +5, +10, I can define like this. As we are in the C program, let me just show here. For I equals to 0, I less than or equal to n, I plus plus. This is what we generally like. So here what is happening in for loop? Initially I value will be 0, I less than or equal to n. I value will increase one step. I will become now 1, then 2, then 3. One step is increasing. Here, if we increase the one step, we can't see that much of brightness variations. You can experiment by changing to 1 as well. So what he did here is Tinkercad guy, he given the 5 as the basic level. So initially it will be 0. If we add 5, it will go to 5, then 10, then 15, then 20. Like that increment is what happening here. So once this is defined, inside, if you see as PWM pins also vary, we should use analog right only. Here the only difference is instead of we using analog pin directly, we are using PWM pin. But the operation which the PWM will give is an analog because it is a continuous. It's not digital 0 and 1. So we should write analog, right? 9 comma, how much brightness it should give is the brightness, the variable. If you want to change this variable name, you can change. Then I'm using 30 milliseconds as a delay. This operation, what will do, it will increase brightness from 0 to 255 with every 5-step increment. Now, once the LED is completely changed to 255 level, now I want to get back to 0. That means I want to turn off. So for that, I wrote the for loop in a reverse direction. For brightness 255, brightness greater than or equal to 0, brightness minus equal to 5. That means brightness will start decreasing from 255 to 250, 245, like this 5 value will get decreased. So same analog, right? 9 comma brightness. So let me change here to 1. Now let's see what will happen. You can see a very slow increment of the LED brightness. Once it goes completely, then it will turn off. But here, if you see, we can't able to understand when the LED is completely turned on because we are incrementing 1 only. It takes more time to reach 255 and we should get back to 0. That's why we had given the long increments. Like now, let me try giving 10. The way it's fading has been like increased because of 10. Now let me increase the delay. Let me make 300. See, as the delay increased, even at the 10 plus 10 step, it taking little time to go into the 255 level and getting back to 0. So this is how we do LED fading. Also, like in C language, if we want to print something, like say a print of hello world, we have a function called printf to write whatever we need to print. But in our Arduino IDE, integrated development environment, if you want to see anything by printing, we can also use here. I'll just show you with a small print statements. So let's print, or println is getting into new line. Hello class. So, okay, now the program has started. See, if you see, was not declared. So here, what I should do is, I want to use, like whenever I'm writing a print statement, I need to use a screen to see whatever I want to print. In your C language, you will have a compiler where you can see whatever you are printing. Here, serial dot begin. That screen here we call as a serial dot begin 9600. So whenever you guys want to see whatever you need to print or whatever we need to take input, we will use a serial monitor. If you see here, there is an option called serial monitor. This serial monitor, you can give inputs to your Arduino board, or whatever it is printing, you can see here in the screen as well. So to start the serial monitor, we will use a function called serial.begin. Here 9600 is called baud rate. This baud rate, the meaning of the baud rate is 9600 bits will transfer to this Arduino microcontroller in 1 second. That means the rate of bits transmission per second. So every different controllers will have a different bitrate transmissions. If we see ESP32 controllers, that will have 115200 as a transmission rate. In Arduino, controller will have 9600. 9600 bits per second rate is what we get from the Arduino controllers. So here, I started the serial monitor, serial.begin 9600. Now, if I want to see anything on the serial monitor, we should write serial.println hello class. Now let's start simulating. So one more thing which we need to understand is whatever program we are using, I mean, whenever we are writing a program, we should also know how to debug this. So let me just show you. So see, now let me clear this. Let me stop simulation again. Now you guys tell me when this hello class will print. At the starting of the program or ending of the program, and why? సో మీకు అర్థమవుతుందండి ఇక్కడ మనం ఏం చేసామంటే మన సి లాంగ్వేజ్ లో కన్సోల్ స్క్రీన్ లో ఎలా అయితే మనం ఇన్పుట్ అవుట్పుట్స్ చూసుకుంటామో అదే విధంగా మన ఆర్డినో ఐడిలో కూడా మన ఇన్పుట్స్ ఇవ్వచ్చు లేదా ఏదైనా అవుట్పుట్స్ చూడాలి డిస్ప్లే మీద అనుకున్నా కూడా చూసుకోవచ్చు. దాన్ని చూసుకోవడానికి మనం యూస్ చేస్తున్న మానిటర్ నేమ్ వచ్చేసి సీరియల్ మానిటర్ అని ఉంటుందండి. ఈ సీరియల్ మానిటర్ మనం యూస్ చేయాలి అంటే వాయిడ్ సెటప్ లో ముందుగా సెట్ చేసుకోవాలి ఐ వాంట్ టు యూస్ సీరియల్ మానిటర్ అని. So for that, I'll use a command called serial.begin with a baud rate, like how many bits it need to transfer per second. That means 9600 in Arduino case. Once I wrote the serial.begin, the program is set it up that serial monitor, the user want to use a serial monitor, you make the serial monitor ready. So అలా రెడీ చేసుకోమని చెప్పేసి సెటప్ లో. ఇప్పుడు నేను ఏదైతే ప్రింట్ చేయాలనుకుంటున్నానో అది నేను serial.print ఎల్ఎన్ అంటే న్యూ లైన్ అని లేదా serial.print అని రాసి ఈ డబుల్ కొటేషన్స్ లో నేను ఏదైతే ప్రింట్ చేయాలనుకుంటున్నానో ఆ స్టేట్మెంట్ రాసుకుని ప్రింట్ చేసుకోవచ్చు. ఇప్పుడు నా క్వశ్చన్ ఏంటంటే ఈ హలో క్లాస్ అనేది ప్రోగ్రామ్ అంటే ఈ ఎల్ఈడి బ్రైట్నెస్ ఆన్ అవి ఆఫ్ అయిపోయిన తర్వాత ప్రింట్ అవుతుందా లేదా ప్రోగ్రామ్ స్టార్ట్ అయ్యేటప్పుడు హలో క్లాస్ అని ప్రింట్ అవుతుందా అని అడిగాను. ఎక్స్పెక్టింగ్ ఆన్సర్స్ ఆన్ దట్.
Starting.
సారీ, see how the program executes. First, setting up is completed. Now it will come to the void loop. The first statement here is for. So this for loop will execute until the brightness reaches 255 or above, that is 256. Then after this loop, it will exit and it will come to here, which will make the brightened LED, that is 255 level LED to 0. Once 0, it reaches to minus values, this for loop will get exit. After exiting, then it will print the statement. If serial.printer. If we run the simulation, see now LED started increasing the brightness, but in serial monitor, there is no hello class. LED once it glows to highest 255th level, then once it's getting back decreasing, oh, it's decreasing. It went to 0, then it started, it given hello class. If this is a similar statement, Let me write a similar statement here. Write hello oceans. Now what will happen? As this is the first statement, we'll get hello ocean apps first. Then once the LED brightness goes high and get back to down, get back to zero, then we will get a one more statement called hello class. See, hello class we got. After hello class, again it jumped to hello ocean apps. If I want to make my program to stop after giving hello class for a second, I can write delay some 300 milliseconds. Let me change this. Hello, let me put 5 class. So now I got hello ocean apps. First I got hello ocean apps, then it is executing this for loop until LED brightness goes to high. Then after completing high brightness, it went to here, leading to decrease the brightness level. And then by class, again, after 300 milliseconds, it got hello ocean apps. Now we are not able to understand, okay, when this program is executing, I'll just put one more statement here. Exited first for loop. Here I'll write LED off. I'll just put one small delay here. Delay. I'll put one second. Now let me run this program. Now we can understand, okay, when this is turning off and turning off. Spelling. Starting. Okay. See, now at the starting, I got hello snaps. Now this for loop is executing. Once this for loop ends, I'll get exited first for loop. That means LED went to high state. Now it's going back to low state. So LED off. I got by class, then hello snaps. The program is repeating. So this is how we will write this program. If you want to run this program only at once, you can, if you want to run this program only at once instead of looping it continuously, you should write that program in setup section. Once you write in setup section and run, the program will run only for once. See hello ocean apps. Yes, this is the first statement. Then LED is going high. First for loop completed. LED off by class. See if you see here, the program is not repeating, it's turned off. LED is turned off and it's stable. So if we want to execute any certain instruction only one time, then we will write that program in the setup section. But whatever you are setting here using pin mode commands or serial begin, that will be there for the whole program until you remove it. So like that, we write setup block and loop block. And also, like once you dump the program into this Arduino board, it will be there forever until you redump the new program. So ఒకసారి ప్రోగ్రామ్ చేసి వదిలేస్తే ఈ ఆర్డినో బోర్డ్లో మీరు ఇంకో ప్రోగ్రామ్ రాసి మళ్ళీ ఈ ప్రోగ్రామ్ డంప్ చేసేంత వరకు కూడా ఈ ప్రోగ్రామ్ ఆర్డినో బోర్డ్లోనే ఉంటుంది. It won't get erased. So this is the basic operations which we are performing on the LED. So for next class, the assignment will be with the 5 different LEDs. We will ask you to create a pattern of LEDs, which you will get as a description in an assignment, asking you to perform 3 different operations. All that operations should perform in the single program itself. That we will clearly write and send you what we are expecting to do from that assignment. Okay. So far, is it clear? Like we checked how the LED brightness will on and off. Sorry, LED will turn on and off using a basic program, the digital light operation. Also, we checked how we can control the brightness of LED, like it's basically called fading from zero level to 255 as LED's maximum level is 255 using an analog light operation. Also, we seen how we should initialize, that means how we should begin the serial monitor and how we should write the serial commands, like serial print command, the first function which we tried today. Serial print. Is everything clear till now or any doubts? Also requesting everyone to create a Tinkercad accounts and log in into this. From now on, whatever we are doing, we will use only Tinkercad. And the Tinkercad, we will try to track the assignments in the Tinkercad itself. So if possible, like everyone create accounts here. You can, if your time permits, you can experiment with various things. We do explain all this in our class, in coming classes, like button, debounce, detector, analog input output. So I'll just brief what we will give you in tomorrow's assignment. So let me just throw this out for some time. So, two, yeah. We will take seven different LEDs in a single board. We will name this as one, two, like that. We will name all these LEDs as seven LEDs that we will share you a document like what is the each task is. What I will be expecting in this is the first task, we will turn on and turn off all the LEDs in 1 second delay. Second thing, we will try to turn on diagonal LEDs like this, and a center LED. And third step, we will turn we will turn on all the LEDs at once. And then we will start flickering it, like we will start blinking it. Then we'll change the vibrate, like the brightness levels. Then we will turn off the LEDs. Very simple task, like all should be executed in the one program. The clear description of this task will be given, shared by a document to you all. Hoping you guys will write the program and will submit that program in the Google Form link, which will be shared. This is what will be the task for Monday's class. Okay. Is it clear, everyone? Okay, as there are no other questions, let's wind up this class for today. Thank you all. Thanks for joining.